meter bridges and culverts we actually constructed. You see the resources we actually received from the government and other development partners. Now the annual turnover of LGD is around 3 billion expenditure every year. When you design a project, definitely we consider the Bangladesh Delta Plan, National Adaptation Plan, Perspective Plan, 5-year plan, and other plan, and also election manifesto of the government. Rural infrastructures, mainly the bridges and roads, and also the rural markets, were just to provide the connectivity for the farm and non-farm producers. Also, the marketing facilities of these commodities. How actually decreasing the poverty in Bangladesh is just see. And it is only because of the development of the rural infrastructures. Now the challenges actually we are facing recently, the climate resilience, climate change effect. It is Bangladesh is one of the worst affected country in the world because of climate change. Bangladesh does not play a vital role in affecting climate change. Other countries are doing, but the impact Bangladesh has to take this sort of effect because of climate change. The players are the different countries, the developed countries, but the impact is actually is given to the developing country like Bangladesh. Local infrastructure, see how actually the local infrastructure are affected due to climate change. Major climate resilient rural infrastructure projects. Recently, the government and also the development partners like World Bank, ADB, JICA, USAID, KFW, so many, even 26 development partners are working in LGDs in different development projects. To face the challenges evolved by the recent climate change impact, LGD is not sitting idle. LGD has taken initiative to integrate climate and disaster resilience in infrastructure design, implementation procedure, and also by this time LGD has developed new design standards addressing all climate change issues and developed asset management policy system. We like to introduce asset management in LGD to manage all the assets already developed by this time. I think it is enough to run the rural economy. Also, the system, the online-based, web-based disaster-related rural infrastructure damage assessment system already developed. Any disasters actually occurred in any part of Bangladesh, instantly we can have the data from the field as the web-based DDoS is active in LGD. You know that Climate Resilient Local Infrastructure Center, LGD has established. It is a national center of excellence to address climate resilience. And LGD has been given this responsibility to run this center of excellence, that is CRELIC. Still working. Many national and international experts are working in this center. They are gathering knowledges, best practices, which are used in other part of the world. They are taking, and also they're creating manuals, and also the forecasting. They are processing data also, collecting data, and it's a hub of knowledge. First, they actually collect all sorts of data. Then they modeling, go through modeling and also processing the data. And finally, they generate the reports and also the trend of climate change, climate vulnerability of a particular area. It is not useful only for the LGD officials. It is also any other organizations in Bangladesh. They can share with us. We can provide them knowledge and also the data, what they require. And even we have made the many MOUs, Memorandum of Understandings, with many organizations, both in Bangladesh and also international organizations also, to exchange our knowledge and experience, based practices on climate resilience. LGDs work mainly on mitigation and adaptation. The CRELIC is now under a project financed by Green Climate Fund and jointly by another organization like KFW. They are also providing both technical and financial support to establish full establishment of the CRELIC. And after project period, this CRELIC will be switched over as a government organization, and they will work independently and separately. But they will have this is the proposed CRELIC organogram. Will work in future as an independent and a separate entity. Actually, in design aspects, we actually provide not many options, or only freeboard which increased a percentage of. Previously we actually maintained the minimum freeboard of embankment, but now, and also the slope of the embankment is also mild, making the slopes, but the problem is there for LGD that much space are not actually available to make a mild slope. That's a other treatment option we actually adopt. Slope protection or retaining wall type. Others, nature-based solution like vetiver grass, we provide on the slope, but it is not much popular. The engineers actually working in the fields, they are not much interested to use vetiver grass. The problem are also there because not everywhere these grass are available. It is not much expensive, not cost involving. That's why many of us not interested much, on the contrary, much reluctant to use vetiver grass alternatives, the nature-based solution. You see in cyclone shelter, what type of materials we use in cyclone shelters, which are very much climate resilient. And this is all, actually, I'm not a professional on this particular issue, particular subject. And I would say, thank you all. Thank you, everybody.
Thank you very much, Engineer Muhammad Ali Akhtar Hussain, for your nice presentation. We have learned few important things from his presentation, how LGED is considering sustainable and resilient development approach for their infrastructure development, and which has significant contribution towards the poverty decrease of Bangladesh. And he has also mentioned there are few challenges to accomplish these targets. Now, I would like to invite few questions from our audiences.
The open discussion, or you can have any question or observation, please.
Assalamu alaikum. I'm Ashraful Alam, Director General HBRI. First of all, I congratulate, many thanks to the keynote speaker, Mr. Ali Akhtar, Chief Engineer LGD, for nice presentation. My question is, some contradiction I found in your presentation, like in your presentation, you have said urbanization. Before 5 years ago, it was 39%, but after 5 years, it decreases to 31%. What is the reason? Again, you said in the other slide, our poverty decreasing rate is decreasing. Poverty is decreasing. It is a completely contradictory. if the poverty decrease, urbanization should be increased. Because, as you know, the present government in 2018 election manifesto was our is Amar Gram Amar Shahar. That is, all the villages will be like the town. That is, all the villagers should get all the facilities which get the urban people is always get. But in your presentation, these 5 years that the government manifesto, as per according to government manifesto, government decided to increase the villages to convert into the urbanization. But in your slide, the result is negative. What is the reason? Is it what is
Definitely, I
the
have
source of
reason.
your presentation? Thank you.
Thank you so much, Mr. Ashraf. Reason, definitely, there are some reasons. One of the reasons is the intrusion of rural poor people to the cities. It is actually decreasing because of maybe erosion, less saline affected area. Salinity intrusion, recently it is not taking place. In Satkhira, Bagherat, 10-15 years before, it was very much acute. And scarcity of the drinking water, maybe the migration of the rural poor from the city areas take place very seriously. But recently, last 10-15 years, we did not see much erosion or much saline affected. People are. Another one is maybe urban area is confined. It is not that the development or poverty reduction not directly related with urbanization. Urban area is fixed. Maybe the urban facilities are given to the rural poor, rural people. That's why the people are not going to the urban area. They are enjoying the urban facilities in the sitting at the rural area. Maybe this is the reason. Maybe.
Sir, I would like to supplement with you. This is Mohammad Jamanur Rahman, Superintending Engineer, Department of Public Health Engineering. In response to the question of Mr. Ashraf, I would like to supplement with you. Sir, you are very correct. Urbanization is not directly related to the other factors. We are working for supplying the safe drinking water for the coastal people. You know, we are targeting 4 parameters. One is Smart Bangladesh, second is Amar Gram Amar Shahar, third is SDG 2030, and last one is the 2041, in which you will achieve the developed country target. So, you know, the government of Bangladesh is investing a lot of GOV monies. At present, in DPH is operating one project of cost around $1 billion, 8,850 crore taka, in order to achieve the SDG, as well as Smart Bangladesh, Amar Gram Amar Shahar, and Vision 2041. Moreover, the second one is that especially the government of Bangladesh put great concentration in order to supply safe drinking water for the coastal people. For why we are implementing a special project, three special projects for the coastal people to ensure safe water supply. You are very correct. For why the immigration from coastal areas or the rural areas or the interior remote areas is less.
And another
on
one,
the-
third one is maybe the income generation. Income
Sir,
generating
sir,
activity is also
Sir,
increasing in the rural area.
Yes, sir, I would like to say that point. On the other hand, the employment generation increases in the rural areas for the smart economic interventions adopted by the government. So I think your presentation is very nice and correct. Urbanization will not increase because we are implementing, sir, LGD, Department of Public Health Engineering, and other stakeholders, the Amar Gram Amar Shahar project. So why people will come to the city
Cities,
area?
cities or urban area.
So
No need.
thank you very much, sir. This is all from me. Thank you so much. Assalamu alaikum.
Thanks you for your nice presentation. My name is Professor Radi Al-Zubaydi. I'm from University of Sharjah in UAE. But I am geotechnical engineer, but I will raise some questions which I've been just visiting Bangladesh the first time. Well, I don't think so. You have to mix all the kind of traffic in one main roads. If you call this highway or motorway, it's all, I found it is with 2 lanes, and all type of transportations are in the same way. So you know that security of any country is by reaching any point in that country by creating new roads. So rural roads are very important. I think whatever you say is very important because you have to transfer all the goods from the villages, from other side of the country, from countryside to the center of the city itself. First of all, I think you have to make some TIS, we call it. I think all transportation people, they know that, traffic intensity study. And then you have to decide the number of lanes for that road. So it means that, but I found all the roads are the same design, the same 2 lanes go, 2 lanes comes. So even I found that there is no any space in the side of the road for any extension, which is, I think, where you have to take it into consideration for any new roads. You have to put some spaces or to put any spaces for more extension in the next few years. So when you want to extend these roads, I think you don't have any space now. You cannot find any space. So this is one of the things which you have to keep it in mind when you're going to design road. I think when you want to design road, you have to take a picture from maybe satellite and then you can find the best road to connect all that points together. So what I've seen is sometimes you feel you are not happy with the type of driving, the night drive. A lot of people they are in the same road, so this may be cause a lot of accident. Thank you very much.
You're right, absolutely right, because you will be surprised. The 350,000 kilometer of rural roads, 99% road space is donated by the local people. No lands actually acquired or acquisition actually made for the preparation of any rural roads. Only a small amount of land acquisition actually take place only on the bend or any bridge approaches, not road to actually make land acquisition. This is one thing. If we go for land acquisition to make the very standardized road with standard geometry and standard specification, it will take much amount of resources actually will be required. And this is not possible in Bangladesh still. But we have 3 category of roads. One is a higher category, highest category is Upazila road. Then second highest category is Union road. And third highest category is village road. We actually give importance and priority to maintain the highest category road, that is Upazila road. This is top width is 24 feet. Normally, these roads are embankment width is 24 feet and pavement is 18 feet. But in some cases, we actually increase this geometry, but most of the cases, this is a fact. And another one, the tertiary secondary road is union road. We cannot provide much resources in the rural area. We just give priority only to manage the top priority, top ranking road, that is Upazila roads. And village road, we are not also to develop any new roads like village roads, because only because of constructing the rural roads further, it will create another hazards. Hazards means if we create new road, new settlement will be there. And what would be the consequence? Consequence is the wall utility service will be extended to the new settlement. And finally, the decreasing of croplands. This will not happen further. That's why LGD as an organization not interested to create new roads. Which roads we have already developed. We have to maintain and manage these roads. That's all. And we like to create new township around the growth center or rural roads, so that the scattered settlement will be, in course of time, it will be as a center of growth center of rural roads, so that the scattered settlement will be decreased and the croplands will be reclaimed or recovered. And that's why we're actually implementing the Amar Gram Amar Shahar with the new concept of township development around the rural roads, rural markets and growth centers to save our croplands.
Thank you very much, Engineer MD Ali Akhtar Hossain. Dear audiences, thank you very much for making this session interactive. My apology that we are running short of time. Maybe this is the last question for the first keynote.
It's not a question to Honorable Ali Akhtar, the Chief Engineer of Local Government Engineering Department. It's the substantiation of what our Chief Engineer said, and I would like to give some feedback from Australian perspective. My name is A.H.M. Kamruzzaman. I flew from Australia. I graduated from here, and I worked in a roads and highways department like LGD. And what I would like to pay attention to our professor who flew from Saudi Arabia is that when I drive thousands and thousands of kilometers in Australia from one part to another part, recently I traveled in New Zealand, you could not find a single road which has got a shoulder, right? So what Honorable Chief Engineer said, we have a categorized road. So when we talk about the major roads and highways road with the major connecting divisions, we have a shoulder. When you talk about rural development road in the Upazila and so on, we don't need it. So we need to work with which one is the best for practice, right? So if I talk about developed countries, USA, Australia, New Zealand, I didn't go to Canada. So what I'm saying is when I used to drive thousands and thousands of the regional road, even for a single road, it's a single lane. And there are many head-on collisions, people dying on the road every Christmas time, 20 to 30 itself in a New South Wales. How many people are dying on a particular holiday in Bangladesh? So I would say that Bangladesh is doing an extremely good job. In particular, local government engineering department, thank you very much for your leadership. When I worked in Bangladesh back in 93 to 1996, we used to design only for up to 67 to 70 kilometer of the bridges. Now LGD itself is doing 1.49 kilometer bridge. Roads and highways is doing bridge like Padma Bridge. What a great development in Bangladesh. We have a Kornafuli tunnel, we have a Dhaka-Chittagong highway. I just felt amazed when I come to Bangladesh on and off. So I think good luck Bangladesh, good luck LGD to doing all this good job. With respect to some of the limitations we have, I think we are doing very well compared to many other developed countries. Thank you very much.
Thank you very much. Thank you, our honorable speaker, Engineer Muhammad Ali Akhtar Hossain. for your
Again,
nice
I'd like to
presentation and
express my
also satisfying all the queries from the audiences. I also thank the audiences that we could have learned many interesting information from your open discussion. Now, I would like to present a token of appreciation from our conference to the honorable speaker, engineer MD Ali Akhtar Hussain. So now I would like to start the second keynote of the first keynote session. And I'm inviting Professor Dr. Rakib Hassan, Professor of Civil Engineering, KUET, for the second keynote presentation. Dr. Rakib Hassan is a professor of civil engineering at the Bangladesh University of Engineering and Technology, KUET. He belongs to the Structural Engineering Division. He obtained his BSc and MSc Engineering degrees from KUET in the years of 1995 and 1997, respectively. He completed doctoral studies at Tokyo University in the year 2000 in Japan. His fields of interest are structural dynamics, earthquake engineering, structural optimization, soil structure interaction, structural retrofitting, etc. He conducted a large number of sponsored research. He has published over 80 book chapters, a tremendous number indeed, journal articles and conference articles. He is presently acting as a reviewer in multiple journals. He acted as the coordinator of the Bangladesh National Building Code, updating the project. The National Plan for Disaster Management 2021 to 2025 was drafted under his guidance. He is a member of the American Society of Civil Engineers, ASCE, American Concrete Institute, ACI, International Society of Soil Mechanics and Geotechnical Engineering, ISSMGE, and Institution of Engineers, Bangladesh, IEB. Professor Rakib Hassan is going to present his keynote presentation on utilization of electric arc furnace slag and ladles refining furnace slag in cement and concrete production. Professor Rakib Hassan, I welcome you to deliver your presentation.
Thank you, Mr. Chair. Distinguished guests, my colleagues from KUET, my honorable teachers, my classroom teachers, Professor Azukul Khan sir, Professor Delor sir, my colleagues at KUET and students of KUET and other guests. Assalamu alaikum. Very good afternoon. Before starting my presentation, I'd like to make few comments regarding the topic. Actually, as Azad sir said that some of our works are too fundamental science or fundamental type of research which are not so interesting for an audience. So I was just thinking which topic would be good for this keynote speech. As I'm a structure guy, more than a material guy, so I selected a topic related to cyclic test of masonry structures. But Professor Zakir, he was right. He suggested me that I should change the topic because that is rather conflicting to the idea of sustainable development. You're right. So I changed the topic. I was fortunate that I was involved in a industry academic collaboration project as a co-PI, and I would present the findings of that project. In that way, I can also showcase that industry academic collaboration are going on well in our academia in KUET, and I think that even in KUET. So the topic is utilization of electric arc furnace slag and ladle refining furnace slag in cement and concrete production. Actually, the whole project is more wider in scope. That involved also application of slag in asphaltic concrete in road pavement construction, etc. I'll not go into those topics. I'll concentrate only on cement production and concrete production. Now, why slag? I think most of us are familiar with the idea that slag is a byproduct of steel production, and thus it's a waste product that we need to dump in landfills most of the time. But as we know that in cement, we use slag cement, or in composite cement, we use slag. But that slag is blast furnace slag, ground granulated blast furnace slag, GGBFS. That is the standard. But I'll explain that in Bangladesh, it's very expensive. GGBFS is very expensive and it's imported. In the steel production manufacturing plants in Bangladesh, we don't have any blast furnace. So we don't have blast furnace slag. What we have is most of our steel production is done in induction furnace, and currently few electric arc furnace slags have been commissioned and in operation, and in near future, many manufacturing plants are coming up with the technology of electric arc furnace. So our objective was how to utilize the electric arc furnace slag, and ladle refining furnace is part of it. The whole project that's for further refining, and this ladle refining furnace slag. Now, slag has some advantageous properties. One is that once it is ground, then in fine, when it is fine in particle size, is that it shows some pozzolanic behavior. So that's why we can replace it. We can replace clinker with slag. Secondly, it also shows very good sulfate attack resisting properties. That's why we use slag cement. Is density is higher, although the porosity is high, but overall unit weight is high. That's why we get denser concrete, for example, and its strength is also relatively high compared to other aggregates. So when we use, if we use it as aggregate, it may show higher strength, but these are all left to be proven actually by testing, particularly for electric arc furnace slag and ladle refining slag. But one thing is clear, that slag, since this is a waste product and it causes rather environmental problem, if we can use them in replacement of clinker or as aggregate, it is a greener choice. Now, why we don't have any blast furnace slag in Bangladesh? Because everything is in Bangla. Why? I don't know. There's something wrong. Anyway, I don't know. Can you change the font? Just select it and change the font. No, I didn't write it in Bangla. It was in English. So go to home and change the font type. Anyway, I'll explain. So there are two routes of steel production. One is primary route and another is secondary route. Primary route is where steel is produced from iron ore. It is collected from iron ore, and that is primary route. For primary route steel production, blast furnace is needed. And another is secondary route where steel is recycled. Scrap is used as raw material for steel production. And in the present day world, 90% or more steel is rather produced in secondary route because that is more environment friendly. Now, in secondary route, major a great quantity of furnaces are electric arc furnace. In our subcontinent, induction furnace is also used, but majority of the furnaces for secondary route are electric arc furnace. And in that process, for further refining, ladle refining furnace is also used. Now, the problem is why blast furnace slag is a kind of standard for to be used in cement, because of its properties, chemical properties and chemical composition that can be more controlled. The problem with electric arc furnace and ladle refining furnace slag is that since the raw material is scrap, it depends on the type of raw material that is used to produce the steel in the secondary route. Depending on the raw material, the chemical composition of the slag and other chemical properties of the slag varies in quite a large margin. That's why it is not standardized yet. So our focus was that what is the condition in Bangladesh? We chose one particular steel mill, and we used the slag from different production periods, and we tried to characterize the chemical composition, and you tested the slag for clinker replacement and aggregate replacement. Now, in the context of Bangladesh, 7 million tons of steel is consumed per annum. It may sound like a large quantity of steel, but it is actually not. Per capita steel consumption is only 45 kg. The highest in the world is in South Korea, that is more than 900 kg per capita. Now you can imagine that steel consumption in Bangladesh is quite low compared to other countries. Now, in the process of development, we'll use the per capita consumption of steel will be much higher in future. With that, the slag production will be also much higher. Now the slag production is 900,000 metric tons in Bangladesh, and that is already a problem for many of the steel mills, where to dump them or how to use them. Now in future, when the per capita use of steel will be higher, then this will become further problem. Now, if we compare with USA, Japan, Germany, and France, there 100% slag is utilized in different forms. They are not dumped. So we should proceed to with that goal. Now the slag we collected the slag from GPH Ispat. The collaboration was with GPH Ispat. The electric arc furnace slag we crushed. The slag was crushed in different sizes, like 3/4 inch downgrade, 1/5 inch downgrade, and LRF slag was collected in powder form. We used Iccesd, and we found out that for electric arc furnace, majority were a great portion component of it was iron oxide, like magnetite, woolstite, and some silicon oxide. We'll show other components too. For LRF, interestingly, it has chemical composition very similar to clinker. It has got belite, which is tricalcium sulfate, and alite, which is dicalcium sulfate, and tricalcium aluminate, which are also the compounds of cement. Now, if we see all other compounds, then we can see that EF slag in literature, this is the average kind of average amount of different compounds that are found in EF slag. In our particular sample, this is the percentages were like this. And if we compare with clinker, the major difference in EF slag is that this ferrite, iron oxide, huge amount of iron oxide is present in EF slag as compared to blast furnace slag. Ferrite is almost nil in blast furnace slag. Now, if we compare LRF, then we find that in case of LRF, there is very little amount of ferrite. Majority is like lime and poor silica. If we compare with clinker, this is comparable with clinker, LRF slag. Now, we try to utilize the slag, LRF and EF slag in cement production. The process was like that, like this. With clinker, gypsum was added. Then slag was added in powder form. Both EF and LRF slag were pulverized, and the particle size was lower than 150 micrometer. And then it was added in different quantities, depending on the mix design. And in a small rotary ball mill, we mixed this gypsum, clinker, and slag. So the final product was cement. The mix design was like this. Clinker percentage was replaced. Clinker was replaced by 5% to 30% LRF slag. In number one sample, there was no replacement. There was gypsum only. In number 2 to 4, sample number 2 to 7, there was replacement by LRF slag from 5% to 30%, and sample number 8 to 11, EF slag, clinker was replaced by EF slag from 5 to 20%. Now, after replacement, the chemical composition became like this. In LRF, the ferrite percentage was comparatively less. And we see that when EF slag was replaced, ferrite percentages increased with higher portion of EF slag. And if we see that lime percentage also remained relatively similar to clinker in case of LRF slag, and lime percentage was reduced in case of EF slag. Now, if we calculated the box compound, that is belite, alite, and aluminite, the box compound of cement, and for LRF slag, they were all within permissible limits, but for QF slag, which is EF, electric arc furnace slag, the ferrite aluminite percentage was so low that ultimately other compounds could not be determined, because the formula that we used required that the aluminite ferrite percentage must be greater than 64%. Anyway, now we used scanning electron microscope to see the inner structure of these mortars. When there was no replacement, we can see the lighter shades are actually CSH gel, which contributes to the hydration process, and the elongated needle-like materials are ettringite, which are it fills the air, and the darker ones are Portlandite, which is responsible for density. It contributes to the density, but at the same time, if it is more than some allowable limit, it has an expansive property, Portlandite. So now when we replace with 5% EF slag, we can see that ettringite is more predominant. CSH gel becomes a little less. Portlandite is also we can observe. Then with higher percentage of EF slag, amount of Portlandite actually increases, which shows that the material is becoming more heavy. Density is getting higher. But after certain amount of replacement, it may show expansive property, which is not good for durability. Similar nature is found in 15% replacement of EF slag. Now, LRF slag, in case of LRF slag, we find that lighter shades are more predominant. So CSH gel is more compared to when we replace EF slag because of the chemical composition of LRF slag, which is very similar to clinker. So we can find more CSH gel here and less Portlandite. Ettringite is also found. But with the higher percentage of LRF slag, what we found in EF slag, that ettringite percentage becomes much higher. In this case, it is not so. Portlandite increases, but compared to EF slag, it's much less. Similar effect is found. Now, after that, we tested the cement mortar with the cement fineness. Ultimately, after mixing, fineness increased with the replacement of both LRF slag and EF slag, and that's quite natural because the powder form of LRF slag and EF slag was much particle was much finer compared to clinker. So fineness was higher. Setting time, we measured setting time. It was within the limits, even for OPC, ordinary Portland cement limits. The setting time was within the limits. Soundness was also within the limit, but if we increased the EF slag more than 25%, then it becomes a problem. Expansive properties are then observed. In terms of strength, we find that with higher percentage of slag, actually strength decreases, but we can achieve some comparable strength with OPC with up to say 15% replacement of LRF slag. In case of AF, again, strength is comparable, but it decreases much with a higher rate, with higher amount of EAF slag. So both LRF and EAF slag can be used as replacement of clinker without adversely affecting the cement properties. But LRF slag is much chemically much more similar to clinker. In literature, we found that free lime is a problem for slag, particularly for LRF slag. But we found that for our samples, that was within limit. And loss on ignition was also within limit. So that was all about clinker replacement in cement. Now, we also studied if the EAF and LRF slag can be used as replacement of fine aggregate or coarse aggregate. For that, if we see the grain size distribution, this is the grain size distribution of silt sand. And the samples we used for fine aggregate replacement of EAF slag that was much finer compared to silet sand, which is not good. And LRF slag was already in the, we had to crush EF slag, and we can actually make coarse aggregate with EF slag. But with LRF slag, coarse aggregate is not possible. It is always in the powder form. So LRF slag can be used as replacement of fine aggregate or as clinker, but not as coarse for coarse aggregate. Again, the particle size is much finer compared to silet sand, which is not good. For stone chips, this is the grain size distribution, and only EF slag can be replaced as coarse aggregate. And grain size distribution, it depends on us how we crush it. So grain size distribution can be similar to stone aggregate. And then we use different mixes. In our first trials, what we did is that without any replacement of stone or fine aggregate, and then we replaced EF slag. We used 60% to 100% slag in replacement of coarse aggregate. And for fine aggregate, we replaced 10 to 50% of sand with EF slag and 10 to 30% of sand with LRF slag. In all the cases, we kept water cement ratio 0.45. Then in our second trial, after getting some experience, we used EAF slag, replaced both coarse aggregate and fine aggregate in different proportions, like 80% replacement of coarse aggregate and 5% replacement of fine aggregate, and so on. 100% replacement of coarse aggregate and 15% replacement of fine aggregate together. What we found is that when we replaced coarse aggregate with EAF, with more proportion of replacement, the strength gets higher. So coarse aggregate replacement was quite successful. But in case of fine aggregate replacement, it was not like that. It varied because the particle size of fine aggregate of EF slag was much less than silet sand. We didn't get very good results. And the same is true for LRF slag too. So finally, what we can say that even in case when we use EF slag both as replacement of coarse aggregate and fine aggregate together, the result varied. So finally, what we can suggest is that for coarse aggregate replacement, EF is a very good choice, but fine aggregate replacement is not desirable, number one. And in case of clinker can be replaced for cement production. Clinker can be replaced both by EF slag and LRF slag. But what we suggest is that since LRF slag has no other use, particularly like replacement as coarse aggregate, LRF slag should be used for clinker replacement. And EF slag can be used as replacement of coarse aggregate, both in concrete and cement concrete and in asphalting concrete. In asphalting concrete is a very commonplace. So we were interested in cement concrete. So in terms of cost, this is a very rough estimate. So like 15% replacement of clinker with LRF slag may save 75 taka per CFT of cement, and 100% replacement of EF slag as coarse aggregate may save 250 taka per CFT of concrete, which is huge. If we think that slag is free in that case, because this is a byproduct waste. Environmental aspect is the most important thing, which goes with the theme of this conference. I'll try to give some statistics here. Cement manufacturing is responsible for approximately 9.5% of worldwide carbon dioxide. You all know that construction sector is a very big contributor of carbon footprint. On an average, the production of 1,000 kg of cement emits nearly 900 kg of carbon dioxide. And for Portland cement, nearly 1 ton carbon dioxide is generated for every ton of cement manufactured. So considering that, if 15% clinker is replaced by slag, LRF slag, say, in cement production without hampering the physical and chemical properties as we have shown already with our samples, then nearly 13.5% less carbon dioxide will be produced for cement production. And the production of 1,000 kg of cement will emit 865 kg of carbon dioxide, which will be like 35 kg less than the conventional process. Not a big gain, but still it will contribute to lessen the amount of carbon dioxide in the atmosphere, and the problem of dumping the slag in the nature, it will also be kind of solved. I would like to acknowledge RISE. We have an institute in KUET, newly established, which is called Research Innovation in Science and Engineering. The name of that institute. Under that institute, we had this industry academic collaboration between GPH Ispat and KUET. In KUET, MME department and civil engineering departments were involved. Particularly, Professor Dr. Gulshan Fahmida was actually the PI. I was co-PI, and Dr. Mohammad Muqtadir Billah, both of them were from MME. They were, he was also PI. So I acknowledge them. Thank you.
Thank you very much, Professor Dr. Akib Hassan, for your nice presentation, and also a special thanks that on my request, you have changed the topic and accommodated in a very short time. And it is obvious that utilization of industrial byproducts in cement and concrete production is a sustainable approach. However, there are few challenges, as we mentioned, especially the early strength gain and long-term durability. Very interesting, since there are presence of free lime, as we mentioned. So now I would like to invite a few questions from our audiences, and as you may know, we are already running out of time. Maybe I cannot accommodate all of your questions, but only a few questions.
স্ল্যাশ তো বিভিন্ন সোর্স থেকে হতে পারে। সমস্ত স্ল্যাশ কি ইন জেনারেল আমরা বলতে পারি যে এই বেনিফিটটা আমরা নিতে পারি না, কোনো সংশয় আছে এখানে?
হ্যাঁ, সেটাই, এটা সোর্সের উপর ডিপেন্ড করে। স্ক্র্যাপ কি ধরনের সেটার উপর ডিপেন্ড করে। আমাদের পার্টিকুলার একটা ইন্ডাস্ট্রির সাথে কোলাবোরেশন, ওদের এটা কতটুকু ইউজ করা যাবে সেটার জন্য উপর আমরা রিসার্চ করছি। ইট উইল ডিপেন্ড অন দ্য সোর্স, ডেফিনেটলি। এটাই হচ্ছে বড় চ্যালেঞ্জ।
Assalamu alaikum, sir. Myself, Professor Dr. G.M. Sadiqul Islam from KUET. I had a few publication on both EF and little furnace slag. In light of this, I would have some queries, like you have used the Borg calculation rather than X-ray diffraction. That is one. Why did you go for Borg? That is Borg. Borg is a kind of old method where while you have XRD for chemical composition, chemical elemental composition. Another one is why did you use mortar for SEM analysis rather than paste?
Actually paste.
Paste, okay. then it's okay. And another thing is you mentioned EAF is more expensive than LRF. But generally, I'm not clear why EAF, because the lime percentage is low in EAF. But I am not clear from the presentation that why EAF will show a higher amount of expansion. We generally understand that lime is the main component which causes this kind of things. And fineness, sir, again, you mentioned that fineness is reducing, I mean increasing fineness. It depends on your preparation. So if you do more work on clinker finding, then it will be comparable, I think. And another thing is that when you use the replacement of coarse aggregate, then the surface texture, morphology of the aggregates is kind of porous, but it's heavier and stronger. So this is there is a kind of trade-off between the aggregate strength and also its morphology. So what you think is the most important parameter here contributed to the strength, like the porosity that will, I think, negatively behave from the context of durability. But the aggregate itself also very strong. So it is giving higher strength. So that's a few my comments. And also you said the fineness of fine aggregate is lower. That's why you don't recommend, but it also depends on how you process it. So if you make a comparable grading size compared to our sillet sand, then it could be another scenario. That's again my comment. Maybe I would look for your opinion. Thank you, sir.
No, I agree to all of your comments. I agree. If I come from the last comment, the application. Yes, concrete becomes porous, but heavier, denser, and the strength gets higher when EF is replaced as coarse aggregate. Now we have to choose the application where that we need more heavier concrete or stronger concrete with where porosity can be admissible. So it will depend on the application. So these are just what to say. We explore if they can be utilized. That's one thing. We have to choose the application definitely. Secondly, the first question, the second one, the box compound and Iccesd findings. Now we have also showed the Iccesd findings, and at the same time, we try to calculate with the box compound. We have both, and they kind of correlate very well. And what we suggest is try to show that alumina ferrite amount in AF is much less, which may not be desirable. And regarding the expansiveness, yes, quick lime. If we have a free lime, then that causes that affects durability very adversely. What we found is that for our samples, the amount of free lime was within permissible limit, less than 5%. So that was not a concern. But the basic inner structure of the cement paste with EF replacement, the Portlandite percentage gets bigger. So the very nature of Portlandite is that it has got some expansive properties. So that may cause some adverse effect if we have very large portion of replacement of clinker with EF. But in consideration of strength, we cannot go that far. That's true. So if we consider the reduction of strength, so we'll not use that much amount of EF, which can cause the expansion of concrete. You're right. Yeah. Right. very good question, but I don't know if I'm the right person to answer that or comment on that. But one thing I want to say is that this flag, this is not standard. So anyone can have a reservation about this. These are just exploratory experiments that we are just looking into it, if that can be used or not. So to standardize these, it will take a long time and a lot more research will be needed. But Portland, the composite cement, this is standard. It is already there in ACI, in all the standards, and it has got so much beneficial effect in terms of durability and other things. I don't know why our government agencies are so reluctant about this. If you want to have very high strength concrete, then you can go for Portland cement. Other than that, for normal strength concrete, composite cement is the best choice. I don't know. This is kind of standard all worldwide. I don't know why the reservation with our government agencies with respect to Portland cement. But again, I'm not a material guy, so I don't know. I should comment on that.
Thank you, sir. We are already out of time. Maybe I can take only one last question. Yes. Azdur Rahman, sir.
Thank you. Finally, just question as such now, query regarding your work. That it appeared to me that you were concerned about the particle size distribution more than the other properties that are required for coarse and fine aggregates. Their mechanical and chemical properties.
We did that, those tests.
Okay,
Yes, I
your
didn't
presentation
present.
did
I
that.
didn't
So
present.
that was my just
Yeah.
passed my mind that we are when selecting a particular
But
coarse aggregate.
Those mechanical tests were within limits.
Yes, sir.
Like,
Okay. So that was not presented.
yeah,
Thank you
that
very
was
much.
not present.
Sir, thank you very much. In fact, we have few more session following this session. We have a lunch event. So if we could not finish this session in time, we may be in trouble for the following session. I know there are many interested hands in the house, and my apology that I could not accommodate all of your questions because our time is very limited, but the session has been very interactive. And I also thank Professor Akib Hassan for satisfying all the audience's queries. Now we will present a token of appreciation to Dr. Akib Hassan from the organizing committee of our conference. Can we please hand over the microphone to Dr. Kamrul Zaman?
No, sorry to volunteer the questions. I'm sorry for it because when some questions come to the audience like this, we must not take a wrong message. That's what I always try to be proactive in any conference, whatever it is. We must not give a wrong message so that people take the wrong message and start to utilize on it. Now, thank you, Rakib, for your nice presentation. In terms of application of the slag, in my roads and highways department in Bangladesh, you probably said that some of the government department, they don't want to accept apart from OPC. So like LGD or roads and other, there are many reasons for it, right? Roads and highways department in Australia only managed to utilize, take note, only managed to utilize the use of slag up to 25% in deep soil mixing and ordinary concrete in last 5 years. GGBFS, the general composite cement, that's what I'm saying. Select channel, right? So the use of composite cement in overseas, like in Australia, it just started only a few years back. So in order to get that research outcome, what Rakib said, it will take some time. We need to change the perspective, quality control. So I would suggest let alone not blame the government department. Work very cooperatively, take some very pilot projects, take the output. The problem with our industry colleagues is they really don't want to get that cooperation, and they probably feel so shy that how do we reach the chief engineer? Can he give a funding? We need to know how to reach him or her. Try to do some pilot project, and once that is proven, definitely we will be convinced. And some of the executive people, they are not structural engineer, they are not concrete engineer. We need to go and convince them. So that is the core message I would like to say. Is I'm pretty sure that Bangladesh will be using all over world technologies, but just be patient. It will be used. Thank you very much.
Thank you, Professor. So this is the end of our first keynote session, and I hope your good stay for the following events at KUET. Thank you once again.
Thank you, sir. Now I would like to request Professor Dr. M. Ajadur Rahman, the chief guest of this ceremony, to present token of appreciation to Professor Dr. Abu Zakir Moshe, sir, head of the Department of Civil Engineering, KUET. Thank you, sir. That's the end of our first keynote session. Our parallel technical session will start at 2 p.m. at the Department of Civil Engineering, following a break for prayer and lunch until 2 p.m. Wish to see you all there. Thank you all.